How array lists work. In this video, we will discuss how array lists are able to grow and shrink. In the previous video, it was discussed that array lists, unlike arrays who have a fixed size, can shrink and grow. What wasn't discussed, however, was how they're able to do that. Consider this program where we declare an array list of integers. As you know, when you create a new array list, they all start off with an initial size of 0. What was not mentioned, however, in the previous video is that when you create a new array list, behind the scenes, an instance variable array gets initialized. In this video, we assume that the initial size is 4, but in actuality, we don't know what the exact initial size is. Only the Java developers know that. But that's totally okay, because as you will see by the end of this video, the initial size isn't what matters, it's what we do with the initial size. So for the purpose of this video, it'll be totally fine to just assume that the initial size for the instance variable array is 4. That being said, since the length of the array is 4, that means the capacity of our array list is 4. So while our array list is currently storing 0 values, at the moment it has the ability to store 4 values. So just a quick recap. The size of an array list refers to the number of elements currently stored in the array list. The capacity of an array list is the number of elements the array list currently has the room to store, and that is the length of the instance variable array. Going back to our program, so what happens when we call the add method and we say add 5 to the array list? Well, since the array list is currently empty, 5 will get stored at index 0. Then the size of the array list will increase to 1. Next, if we call arr.add10, since we already have a value at index 0, the next spot will be index 1. That's where 10 will go, and then the size of the array list will increase to 2. Next, if we try to add 15 to the array list, 15 will get stored at index 2, the next available spot, and then the size of the array list will increase to 3. Next, if we try to add 20 to the array list, 20 will get stored at the next available spot, index 3, and then the size of the array list increases to 4. Next, if we try to add 25 to the array list, this is where we run into a roadblock, because at the moment, the size and the capacity are equal, meaning we have no room to add 25 to the array list. So what does an array list do when we attempt to add a value while the size and capacity are the same? What happens is, behind the scenes, the array list will declare a new array twice the length of the original. Then, all of the values from the original array will get copied to the new array in the exact same positions they were in the original array. Afterwards, that new array becomes the official array for the array list, and the old array gets destroyed. And since this new array has a length of 8, that becomes our capacity for the array list, 8. So now that we have room for 25, we can now store the value 25 at index 4 of the array list, since we now have room for it. And the size of the array list increases to 5. In summary, array lists grow by doubling the size of its instance variable array whenever the size equals the capacity. Now that we've talked about how array lists are able to grow behind the scenes, let's now talk about how they shrink. Suppose I want to use the remove method. Suppose I want to remove the value at index 6. Before I explain how that would be done behind the scenes, I have a question. Do you see anything wrong with that statement? Do you see anything wrong with me trying to remove the value at index 6? Some of you probably do not, because you're probably thinking, we have a capacity of 8, we have a value at index 6, the default value for integers, thus technically we should be able to remove the value at index 6, correct? Actually, no. This is an invalid statement. When working with array lists will only allow you to access elements between 0 and size minus 1, inclusive. Negative values won't be allowed, and any value that's greater than size minus 1 will not be allowed, even if that value is less than the capacity. So even though our capacity is 8, since the size of the array list is 5, the highest we can go is 4. That's the highest index we can access. And that goes for the get method, the set method, any method that requires accessing values at a certain index. All right, that all being said, now that we know removing at index 6 is not possible, suppose we try to remove the value at index 1, which is a valid index. How will the array list handle that? What's going to happen is that every value after index 1 is going to shift one spot to the left. That means 15 is going to move up 1, 20 is going to move up 1, 25 is going to move up 1, and then we can simply put a default value at index 4. And then since we just removed a value from the array list, that means the size of the array list will decrease by 1 back down to 4. Now that the size is 4, that means the highest index we can access in the array list now is 3.